Okay, next I'd like to look at examples to compute a weighted mean. And this just means that you have a frequency distribution and you want to be able to calculate your mean when you have something that occurs more often. Now, the first example that I'm going to show you is a typical type of problem for computing GPAs. So let's look at our example. We have Sue, who has grades of an A, a B, a C, another A, and a D. The courses that she's taking, she has credits that goes along with those particular classes of 2 credits, 3 credits, another 2-credit class, or 4-credit class, and a 3-credit class. And they correspond in the same order as her grades. And then she has, at her school, she has an A equals 4 points, a B equals 3 points, a C equals 2 points, a D equals 1 point, and F's equal 0 points. And so we want to calculate her GPA. Now, in order to do that, we're going to make a little table here, and we're going to put her grades in. So she has an A, a B, a C, an A, and a D. And then we're going to put in the values, her credits. So the first class is a 2-credit class, the second class is a 3-credit class, the second one is a 2-credit class, the fourth one is a 4-credit, and the fifth one is a 3-credit class. And then we're going to put in the values for the grades. So an A is 4 points, the B is 3 points, the C is 2 points, the A again is 4 points, and the D is 1 point. And so then in this credit we're going to calculate. 2 times 4 is 8, 3 times 3 is 9, 2 times 2 is 4, 4 times 4 is 16, and 3 times 1 is 3. And so then we want to get some totals here. So we first want to add up the total credits that she's taking. So that would be this first column, 2 plus 3 is 5, plus 2 more is 7, plus 4 is 11, plus 3 more is 14 credits. And then we want to add up her quality credits, which is the credits times the points for the grades. So 8 plus 9 plus 4 plus 16 plus 3 should give us 40 quality credits. And then to calculate her GPA, we will do 40 divided by 14. And so that turns out to be 2.86. And I didn't say that we did want to round to 2 places when we did that. So that gives us a GPA of 2.86. And so that is an example of how to do a weighted mean. Now, taking that same principle, we're also going to take that theory and apply to finding the mean for a frequency distribution. So that formula looks like this. The mean would be the frequency times the value divided by the sum of all the frequencies. So we have a table where we have the data, and then we have the frequency. So we have 0, 1, 2, 3, 4, and 5. The frequencies are 2, 1, 3, 12, 16, and 18. And then we need to add a column where we do the frequency times the data item. And we calculate that. So 0 times 2 is 0. 1 times 1 is 1. 2 times 3 is 6. 3 times 12 is 36. 4 times 16 is 64. And 5 times 18 would be 90. And then, similar to how we did the weighted mean, we need to find some totals here. So we need to find our total frequencies, which is going to be 52, and our total of the frequency times the data, which is 197. And so then to find that mean, all of this means that value, 197, and this means this total, 52, which gives us 3.788, which we will round 2 decimal places, 3.79, to give us that mean for that frequency distribution. So again, we took how we did this weighted mean and applied it to the frequency distribution, and they are very similar types of problems that we can do. My last example for this video is for a grouped frequency distribution and how to do that particular problem. And what really makes this a little bit different is we have to think about the midpoints for a grouped distribution. So this is a grouped frequency distribution. And we are finding the mean of it. So we have, again, in our chart, the group, the values from 1 to 5, values from 6 to 10, values from 11 to 15, and from 16 to 20. Now, what we need to do is to find the midpoint of each of these groups. So from 1 to 5, that midpoint value would be 3. And even though it is a midpoint value, we're going to use it like our x value that we used in the frequency distribution. And so the midpoint of this group between 6 and 10 is 8. The midpoint between 11 and 15 is 13. The midpoint between 16 and 20 is 18. And after that, the problem resembles the one we just had done, where we have the frequency, which is 130, 250, 230, and 180. I thought we needed to use some larger numbers this time so you could see what happens there. So we have x times the frequency in this column. So 3 times 130 would be 390. 8 times 250 is going to be 2,000. 13 times 230 is 2,990. And 18 times 180 is 3,240. And now we find our totals. So the total on the frequencies is 790. The total on this column, our value times the frequency, is 8,620. And again, to find our mean, we're going to take that 8,620 and divide it by the total frequencies. And so that gives us our value, 10.911, rounding to that 2 decimal place, 10.91. If we're following our rounding rule, since these were all whole numbers, we're really only rounding to the tenths place there. So that should be 10.9. So there again, that is finding weighted means. If you go back and look at our first example, we did a grade point average with our quality credits. Each of you should be able to do your own GPAs for each semester or your cumulative GPA. Frequency distribution, how to do the mean, and then even with a grouped frequency distribution where you have to find your midpoint first and then you calculate that mean.